Well, hello everyone. My name is Goran. I'm working at Endava, and today I'm going to talk about a little bit about C++ for mobile developers and what is happening with C++ in a mobile world in general. So I don't see too many people here in the rooms, so I assume that everyone that is here are actually very passionate about C++. At least maybe my two colleagues in the front are not, but okay. So I don't want to go too much into details, but I just want to present what is the main purpose in general for C++ in a mobile world. So goal of this talk will be to show you some techniques how you can develop cross-platform applications for various mobile devices, and maybe to talk a little bit about C++ and to present it in a better way today, because when you mention C++, actually everyone is pretty much scared. Because one time when I asked someone, what do you do actually? Do you use Java or C++? Okay, I'm using Java, but I use C++ in faculty, so that's the only touch with the C++ at that point. So I want to show you that C++ is actually a modern technology today and not an archaic thing that is a matter of the past, actually. And let's look a little bit. Let's look mobile market share today. So I pulled out this chart from net market share, and I think that these percentages are pretty much right when it comes to what is the percentage of Android, Windows Phone, and iOS and other operating systems currently in the mobile world. And as you can see, Android is dominating here, and iOS is the second most popular mobile system. And now is the time for a little disclaimer from my side, and that is that I'm not a mobile developer, so I'm a C++ developer, and I'm just playing a little bit with mobile OSs, and I want to introduce to myself actually C++ in a mobile world, and maybe to everybody else, because when you mention when you say okay, I want to develop a mobile app, what do you think about first? What is the technology that you think of first? Okay, Java if you're developing for Android, and maybe, I don't know, Swift or Objective-C if you're developing for iOS mobile systems. So basically this is today's market share, and we will see different approaches and why why you must know how to develop mobile apps very fast on various platforms, because the market is demanding. You have a lot of mobile devices today. You have maybe you use Android at home, and maybe you have a business cell phone that is an iOS device or something like that, or you have an iOS tablet or something similar. So basically, the first approach that you can see in almost 90% of the companies that are developing mobile apps is this one. This is a silo approach. And basically what it says is that everybody is doing their own work separately. Nobody knows what the other guy or the other party is doing. And the business logic actually is separated in two different places. So if you're a company that develops mobile app for something, I mean it could be a game or something like that, then you can usually see different branches for different operating systems. For example, you can see completely separate branch with Java code if you're writing for Android, and Swift, Objective-C, whatever, for iOS. And there are some pros and cons with this approach. Of course, pros are that you can use the complete SDK of your platform that you are developing on. So if you're developing for Android, then you have the complete Java SDK in your hands to do whatever you want, and you don't have to think about and to worry about third-party libraries and such other minor things that are not actually related to the business logic itself. So that's the major thing that is good about the silo approach, so to say. But on the other side, you have higher development cost of developing in such a way. So if someone wants you to make an application very fast and I mean not so fast, but to produce something that is good in a shorter period of time, then maybe you have to take a different approach, because when the release is near, you will have a lot of bugs on different places, on different plates, and actually you will end up with fixing bugs separately for every operating system, and that's not a good thing. And you don't know actually you can have a bug in your code, or for example you can have a bug in a third-party code, third-party libraries that you're using, and basically that's why it's bad to have a silo approach. And as you can see here, I'm now mentioning only Windows Phone, iOS, and Android as major mobile platforms. On Windows, you can dominantly use C++, CX, and that is basically a new way of using existing component object module functionalities. So basically it's a COM, but wrapped in much nicer syntax than it used to be with ATL and other libraries. The other option is, of course, C#, and that's a very well-known option on the desktop and mobile also. And on iOS, you have, as I mentioned, Objective-C and Swift as viable options for developing. On Android, predominantly it's Java. So what do we have next as maybe a different from silo approach? Now let's go to the completely other side. Let's say that you decided to develop an app that is completely cross-platform, and you don't want to have such problems that we mentioned, different bugs for every iOS that you're developing on, and something like that. And you want to have one branch where you will develop and have everything. And of course, when it comes to solving a bunch of bugs, then you will have only one bucket to deal with, and not more than one, for example. Then maybe you heard for these frameworks, you can use already known mobile frameworks for that, like Cordova, Apache Cordova, Xamarin, Unity, Qt, or Adobe Air. And the problem with using cross-platform frameworks is that you cannot have a native look and feel on the particular system when you're using them. So it's rather difficult to achieve something that is much better or looks almost the same as when you're using the native SDK and the native APIs and, I don't know, native UI and something like that. So it's much harder to achieve the same look and feel. And that's why the cross-platform approach is, I mean, it's good, but actually it has his own drawbacks. And of course, it depends a lot which framework do you use, because you can have, of course, lower performances. I mean, speed execution can be much lower, or you can end up with using a lot of system resources for your application. And it's not, actually today this is a big problem because system resources are very limited, like processor power or battery or something like that. Everybody wants to have an application that doesn't consume so much battery. So that was kind of the other side of the story. First side, it was a silo approach, and on the other side, there is a pure cross-platform approach. And what is the common for all these languages that we mentioned before? For C#, for Objective-C, Swift, and Java. The common thing actually is C++. Why? Well, when someone asks you, why do you use that language? I mean, C++ is overcomplicated for anything, and it's too much complicated for developing mobile apps. Let's stick with the C++ when you develop desktop apps, and do not use it when you're developing mobile apps. I mean, it's too much complicated. Yeah, but for every platform that we mentioned here, we have compilers, C++ compilers. So if you're using Windows Phone, iOS, or Android, actually you have very good C++ compilers for them. So kind of C++ is a common denominator for all of them. And I know that people are scared when you mention them using C++ in mobile apps, and actually when you go to the Android NDK page on the Google web page, you can see that Google states also that you should use NDK, Native Development Kit, only when you need it. Please do not use Android NDK if you only like to program in C++. And I agree with that. I mean, I like to program in C++, but I don't want to use C++ every time, especially when it's not needed to do so. So there is a quote that says, when you well, I mean, I'll modify it a little bit. When C++ is the only tool in your toolbox, then every problem looks like a nail. I mean, I modified the quote, and I should say hammer, but yeah. So when the hammer is the only tool in your toolbox, everything looks like a nail. And yeah, that's true. If you know one technology and you stick to it, it's not good. You have to broaden the horizon with different technologies, and you have to combine them eventually. So one of the things also that one of the reasons why you could use, or you should use, C++ is that you can get better performance. And I intentionally said you can. It doesn't mean that you will get out of the box the better performances if you're using C++. Believe me, you can write ugly C++ code that is much worse than any Java code that you have seen. So I saw different C++ pieces that are actually executing 10 times slower than corresponding Java code. So basically, it's not that you have to use it always and that you get out-of-the-box performances. But if you search a little bit, you can see that almost, I don't know the exact percentage, but almost any game that is developed for mobile uses C++. And that's not by accident, actually. So it correlates with better performances if you are using it in the right way. So what are our options on different mobile platforms? So we have different development tools, actually, and I summarized them a little bit here, and maybe this is not a complete list, of course. Maybe you use something else, I don't know. But actually, this is a summary of all the tools. So you can see that for every platform, you have appropriate C++ compiler. And on iOS, it's Clang. On Android is also GCC, and on Windows is Visual C++. And nowadays, it's not only a Visual C++. Of course, you can on Windows also use Clang within Visual Studio, and you can see that also Microsoft develops their tools in that direction. They are actually now more focused on mobile, on Android, and on toolsets for that kind of development. And what is the architecture, the main architecture of mobile app if you want to use C++ for some common business logic, so that you avoid silo approach that we mentioned? Of course, for every application, it's very nice to have a native UI. So it's very nice to have the application that behaves in the same way as the other applications on that system. Maybe you used to some kind of notifications on iOS, you like them very much or something like that, and you want to develop something that looks very similar. You don't want to develop an app that looks completely different from the ecosystem that is actually running on. So you want to have the UI that is actually the same as other applications are using it on that system. The other thing that you have to solve how to bridge UI layer with the business logic layer. So basically, if you're developing your application logic in a different technology like C++, you have to provide some form of communication between these layers. So actually, here the thing that you see here, language bridge, is the layer that supports communication between actual logic that you will spread across all of your branches for different operating systems and platform-specific user interface. So when we are talking about UI layer architecture, the most important thing maybe in such architecture is that you have as much as possible thin UI layer, because you don't want to have business logic incorporated in UI layer. You want to have separated it out. And UI layer is only supposed to draw activities, buttons, text box, or whatever, and nothing more, and to communicate with the lower layers. And actually, why it is good to use native technologies for that platform for UI developing is that you have code that is familiar, that you are familiar with. For example, if you're developing an Android application, it's okay to use Java for developing UI layer. You don't want to implement it in C++, of course, because you already have a large code base and large knowledge and a large base of idioms how to develop a UI layer when it comes to Android applications. So you don't want to stretch the business logic and use C++ even for some things in UI layer, because it's just a troublesome. And basically, UI will just call some functionalities in your lower layers, and that's its purpose. And what about this thing that is called language bridge? Language bridge actually needs to hide all the boilerplate logic that you write in your own way when you don't have such tools. For example, if you're using C++ and C libraries on Android, actually you have to use maybe JNI or something like that, and it gets very ugly. So if you whoever wrote an Android application or something like that, or even desktop application, desktop Java app that uses JNI, and you know probably that you're just looking for trouble when you're developing in such a way. That's why you have. It's good to have some kind of automation of these processes. You don't want to think about how to write the separate language bridge for every application that you're developing. So in some way you want to automate that process. And we have to, of course, start from scratch, start from some beginning. We have to provide ourselves with adequate tool sets to move on. So basically, C++ support is very scattered. So on different platforms, you have different possibilities, different tool sets. There are compilers that do not obey C++ standard and something like that, and you end up with a code actually that it's not compilable with a different compiler and something like that. So, I don't know, one of the examples, I can say that Visual C++ is getting much better these days, but it was pure hell using it as a cross-platform tool before, because actually it does not respect so much of a C++ standard. And of course, you have different bugs and different STL implementations. Actually, you have to choose some tool sets that are common, that you can actually use on any platform in order to avoid more and more bugs. And what also you have to do is to develop your own libraries that are missing on the particular system. When you're developing an application with your own with native SDK on some system, for example, you're using Java SDK, you have all the libraries in the world available, waiting for you. And also, when you choose to develop lower layers in C++, it's your responsibility to choose appropriate libraries. Or if there is no library for some task that you want to do, you have to fill the gaps and write it yourself. So basically, one of the most important things, of course, in mobile development are networking and HTTP. So actually, this is the most important stuff that your application will probably need. So there are two options actually here. There is an option to use native libraries, as we already mentioned, and there is an option to use some portable C++ libraries. Each way you choose has his own drawbacks and pros and something like that. But actually, if you choose to have C++ libraries, then actually you have large code base of and large amount of people that already uses some libraries that are well known to the native C++ developers. So basically WebSockets, libcurl, OpenSSL, and something similar. It's very well known between native developers, and it's not such a waste to use those libraries because you know that if you have a problem, actually you have a community that will resolve that problem, and basically you are in a position to patch it quickly. But again, everything is up to you. So you're the guy that you're choosing a particular library, and it's your own responsibility. If you're using native libraries for that platform, for example, from Android SDK or something like that, then you have benefits, some other benefits actually, that you actually don't have to think about patches or something like that on your own. Actually, you will be covered probably with the next release cycle of Android SDK or something like that, and you will have your issues fixed. But what is a drawback of that approach is that again you're on a different court. You're using something that you have to split. You have to have separate libraries and maybe separate network logic for iOS and separate for Android or something else. Aside from network libraries in general, the next problem that you have to deal with are threads. Threads in Java and C++ don't like each other so much. And actually, whoever used JNI knows that stopping threads and controlling them from C++ and vice versa is not an easy task. And I don't want to mention if you want to throw exceptions between threads or to do something like that, then you're in a pure hell. And actually, there are a lot of issues with that, and it's difficult to debug such things. Actually, you can spend more time on debugging and resolving some obscure bugs, and I don't know, maybe 20% of the time you will spend on developing your application and your real logic. And we are going to see how can we bridge C++ with Java. So I chose Java, and because maybe because Android is predominant platform, and I don't know, I worked with GNI and not so much with the other side, Objective-C and Swift, and that's why I'm using GNI as an example. So actually, if you if you used C# and .NET, you know, of course, also what is GNI and what is in .NET platform, what is a painvoke. So that is actually a way to load native libraries and to communicate with them with a subset of common primitive types and special function manglings and something like that. And API, there is a API that provides you the way to communicate with the native code. And there is there any problem with the GNI? Yes, there is. The problem is that GNI can be very slow. It doesn't want to be abused. I mean, it's not idea to call native functions in iterations or something like that. When you're in a native code, stay there. stay there and do something useful and then return the results back. I mean, do not use GNI, please, just for writing a function that multiplies two numbers. I mean, that's tremendously. It's not a. There is no performance benefit in doing that. So, actually, use it for something more complex. And actually, when you have a need to develop something for a specific hardware, maybe you have some kind of specific hardware that you need to access to on your device. So I don't know if it's a different chip that you need to access to or something like that, then maybe you have to use already developed C libraries or C++ libraries. And that is the only time when you should use actually GNI and all of these. In every other situation, if you do not have if you don't have to develop applications for different platforms or something like that, it's probably better for you to stick with Java. If you're only developing for Android. Maybe with an exception if you're developing games and some other CPU intensive applications. So as I mentioned, there are a lot of problems in using GNI. It's not without problems, and actually that is a C API. It's not a C++ API. So there are a lot of things that you have to worry about marshalling your data across the boundaries. So, for example, it's easy to marshal simple types like integers, longs, or whatever. But if you have a little bit more complex structures, then you are stuck with code with tens of lines of code that just converts you one string to another. I don't want to even mention the trillions ways of encoding a string. So if you have to translate Java string into a C++ code, you have to worry about is it a UTF-8 or it's a Unicode or whatever. I mean, a lot of possible spots for problems. And as I mentioned, calling C++ code from Java is actually done with calling special magic names that are created. You can customize that a little bit, but usually it's practice not to do so. Basically, the C++ names that are called are based on package names and actual function or class names in C++. And in the opposite way, if you want to use Java code from C++, you have to actually use reflection to instantiate and to create your own instance of virtual machine and to search for classes, types, and their functions in order to invoke them dynamically. And because it's a C API and because you have to use reflection in one way and you have to use complex marshalling in the other way, you're out of the any type safety that is well known in C++ or in Java. So basically, you're in a land that doesn't respect type system, and if application crashes, it can be very difficult to find such bugs. And here is a little example here that I wrote. It's nothing special actually. It's just one Java class that will be used from C++ code. And actually, as you can see here, I can just, yeah, okay, this works. So as you can see here, I have this magic long pointer here. Actually, that's a way to provide C++ object holder in Java within a Java class itself. So I cannot use C++ names here in Java. I have to hold the pointer in some other way. And as you can see, if I want to use get square function, this is what I have to do here. So I have to find what is the type of my class. I have to find first a method that will get me out the pointer for C++ object that I want to invoke on. And actually, this is this argument here actually explains what is the prototype of this method. It actually says that it doesn't receive any argument, but returns long. This is actual shortcut for long in GNI. Next step is to find the right method and to call it. And then I'm calling this get implementation to get the pointer to the C++ object. And there is a bug in this code, and you can ask me, you can tell me where is the bug actually. And here I'm just casting this pointer back into the real C++ object, and then I'm just calling that object with the supplied argument here. Do you see any bugs here or any? So actually, it's very simple. I didn't want to put something very difficult. It actually has to do about passing arguments. Yeah, okay, so if you cannot spot the bug here on this slide, that tells me that actually this is a boilerplate code that we should avoid. So that's the conclusion. If you cannot spot a little bug here, what would happen in a much larger code base when we have to say? Yeah, actually that's the magic number that I placed here, and actually this code this code compiles. Why not? And is it okay? Well, yes, it is, because this is a C API, and C API also supports variadic functions and etc. And this code compiles actually, but it's gonna crash, because you're supplying an argument to the function that actually does not receive any argument here. So you're out of any type safety here, and that's very dangerous. And this is just an artificial example, of course. I mean, you can have much complex examples that can invoke much more trouble. And actually, yeah, we want to avoid this. What are the results here and the conclusions? This is error prone, of course. And you didn't even want to read the complete code, because it's a simple class that actually doesn't do anything but calculating the square of a number. So because we want to avoid that, we want to use something much more smarter in order to generate this code for us. So that's why today I'm introducing DJINNI. Yeah, I think it's pronounced DJINNI. DJINNI is made by Dropbox, and actually it's a library that generates for you the appropriate language bridge. So, for example, if you want to cross boundaries between Java and C++, then you don't have to worry about this code that I shown before with JNI. You can use DJINNI in such places, so that you can focus on your real thing and your real logic. So DJINNI supports actually not only Java, but it supports Objective-C, and in recent months I think that Python is also supported, and actually now it's possible to make bridges between these languages in both ways. And what actually you can do with DJINNI is that you can define what is the layout of your class, what are the functions, the members of the classes, and actually the tools will provide and generate code for both sides, for Java and for C++. And when it comes to iOS and Objective-C, actually it's a little bit easier to do the bridging between C++ and Objective-C. It's you're going to use something that is called Objective-C++. That language actually does not exist, but it's a mixed Objective-C and C++ code because they have almost the same ABI, and that's why you can mix them in one source code. Of course, there are a lot of problems that you have to solve there, but it's a little less worrisome than using GNI in such a way. So what DJINNI supports is a definition language. It's like IDL for component object model for Microsoft COM technology, and it can provide you with simple tools to define your IDL and to, in short, I mean, you can define your IDL in a very simple way, and you don't have to worry about the other details. So I'll take off this because actually it doesn't work anymore, I think. Yeah, I think it's okay. Yeah, and it supports. Can you hear me? Yeah. It's okay. Okay. Yeah, and it supports interfaces, supports classes, supports structs, supports primitive types, and some even complex types. So we can see here these are the primitive types that DJINNI supports. And here we can see that list, set, and map are used. Actually, those are in C++ unordered variants. I mean, this is a vector in C++. This is an unordered set, and this is an unordered map. And in Java, it's a hash map, and something that you used to use. And actually, there is one type that is used in DJINNI that is not supported in standard C++. It's optional type, and that is for nullable values. Actually, in Java, you are returning object by reference. It's a natural way to do so, and you can return null. And it's okay for your function to return null, but in C++. The value semantics is predominant, and you have some other way to return nullable object. And actually, you don't want to use smart pointers for such tasks because it's not a complicated thing. You just want to have a way to return nullable value. It doesn't have to be a smart pointer that reference count the objects or something like that. So then you're returning optional, and the optional class will be supported, I think, in C++ 17. It skipped C++ 14, and yeah. How can we do better with DJINNI and IDL that I mentioned? What about this? So this is the only thing with DJINNI that you have to write, and you will have generated all the boilerplate code that we already mentioned. And maybe you will not even talk about GNI anymore. So you will have Java interfaces created that you have to implement and to provide the implementation. And on the other side, it's similar with C++. You will get pure abstract classes that you only have to provide implementation for. You can find DJINNI on the GitHub. Actually, it's an open source project right now. and you can use it right away. I mean, the things that get created from the IDL are the list of files, Java files, C++ files, and GNI glue that you only import in your project, and you don't have to worry about those bridging between Java and C++. And maybe one more thing that I wanted to mention about C++ only is actually it's not an archaic language anymore, at least. It was an archaic language maybe 5 or 6 years ago, something like that. But today, this is a modern language that from 2011 till today, it has much better constructs, much better support, and much larger standard library that you can use. And it's well known that somebody will say, okay, you have to deal with memory management, with different threading systems, with different multi-threading libraries on various systems. But today you don't have to bother with that, because everything is a standard library. And this is the brief list of features that C++ now supports. I will not cover all this up because maybe my time is up, but you can search about every of these features in C++, and you can see how they are used and why C++ today is a modern language. And even I can say now it's a more functional language than it used to be, and supports more software paradigms than it used to do before. So C++ is not only object-oriented language. It's still a procedural language. It's still now it's a functional language also. And what is the most important thing, maybe, that it has backward compatibility. So 25 years of backward compatibility, that's a good thing. You know, you have a lot of C++ libraries that are laying around for decades, and they can be used today. And even about that, you can use them for developing mobile apps. So this is a conclusion. And actually today, you get to, you have to know more than one technology to develop even desktop applications, not only when we are talking about mobile applications. You have to use more than one technology. You have to be efficient in more languages than you're used to. So you do want to avoid the silo approach, because it leads to something that is not so effective and more error prone. And now today there are various tools that can help you with that. So Visual Studio, Microsoft Visual Studio, Android Studio, and other popular IDEs now support natively C++ development for mobile. And I think that's about it. We have maybe time for questions now, so thank you. This is the only colorful slide in my presentation, I might say. So
Hello.
Hello.
Could you compare DJINNI and
Yep.
GNIrator?
Sorry, I didn't hear you. DJINNI and?
GNIrator.
I'm not aware of.
GNA, Java Native Access Library for.
Yeah.
Do you know Java Native Access?
Not so well. Actually, I've used only GNI for this, because well, I'm primarily not a Java developer, and I'm not so familiar with different native techniques. But yeah, okay. I mean, GNI is the only thing that I've used.
Hi. So basically, I wanted to ask you to make a comment about can C++ in mobile development give us more possibility or more direct access to the hardware, like sniffing complete network traffic or getting raw data from the camera feed? Sometimes we need that to optimize or to make our application even useful. For example, we want to make a security application that will monitor all traffic. And unfortunately, if we use, for example, Android, we have Java that restricts some access, then we have a framework that give us additional restrictions. So can C++ in those situations solve that? So can it give us more possibility than using just the Java or the platform language?
Yeah. Well, it can help you, but there are two sides of the story. With Android SDK, you have far more APIs than with Android NDK when you're using only NDK for developing apps. And of course, you can go to the bare metal and go through the documentation how to use some of the functionalities of your device, for example, camera feed, but it can be difficult. I mean, I can say only that it maybe can be efficient, but I for sure know that it would be difficult to do so. So the only time when you will use that is if you have very good reason to have such performances or something like that, and actually when you want to avoid. Basically, what I was talking about here is not using device-specific hardware. So this talk was much more about business logic, that it's not dependable, that it doesn't depend on hardware itself. Maybe you will use again Java SDK or something like that to provide some information from the hardware-specific things.
Yeah, so basically I just wanted to check if maybe it can be a good use case to use C++ when, for example, you want to make an application, for example, for security reasons to monitor all traffic, and you just can't do it in Java. So you can't access all network traffic.
Yeah, well, you can access, you can have an access with, in C++, but I cannot say for sure that it won't be difficult. I think that
yeah, but it at least give us an option.
It's possible, of course.
Yeah, thanks.
Yeah. So, yeah, if there's a question. So, okay, if there is no more questions, I can conclude this talk. Okay. Thank you.